plane given by the following 3 pairs of parametric equations. Nice. So what did you try to do on all of these?
So I substituted x to y.
Yeah, so in A, what did A become?
Y equals x squared.
X squared. And what did B become?
They're all the same.
Okay, so you know y equals x squared, and C, y equals x squared.
Yeah.
They all have the same what? So therefore you know that they're all on the same. Yeah, they're all on the same path. That is correct. That is correct. But how would you then? What else did you say? Talk about
Velocity.
the what?
Velocity.
The velocity. Exactly. So on A, so this is the path right here. You could talk about the velocity of each one. So for A, you have a velocity vector of 1, 2t. For B, you have a velocity vector of 3t squared, 6t to the 5th. Is that correct? Yeah, right? Oh, no, that was C. I just flipped that, sorry. So that's C right there. And then B is 2t, 4t cubed. Got it. So what could you conclude from that, Henry?
That A is the slowest, C is the second slowest, and D is the fastest.
Slow, medium, and fast, although medium kind of sticks there. Slow, fast, and faster. Correct. At any given moment, as long as t is positive. Well, actually, no. If we did the absolute value, so you could do this. You could turn it into speed with the magnitude, but the idea is that they're not going to be in the same place at the same time. So, that would be another observation you could make. Are these ever going to be in the same place at the same time? Except at 0, 0. Are these ever going to be at the same place at the same time?
1, 1.
Oh, at 1, 1.
No.
No. At 1, 1, they would be at the same place. Yeah. Because at time 1, what are they all?
They're at 1, 1.
They're all at 1, 1. What's interesting though, can I just point out something? For the time between 0 and 1, is this true? Slow, faster, fast.
Only after 1.
Only after 1. This is for t greater than 1, because before 1, this one's actually slowest, right? Do you see why, everybody?
Yeah.
If you plug in a number that's between 0 and 1 and t to the 3rd, t to the 6th, what happens? It gets smaller, right? It shrinks.
That's interesting.
That's kind of cool. So you could say that's from t equals this, but then you could say for t less than 1 but greater than 0, you end up with faster, fast, and slow. It's kind of cool.
Wait, doesn't C get like?
Find the arc length. Yay! We love arc length. We love it. You will love it. You will love arc length. You'll will it over there. Jesse is a little skeptical right now, but I think he's getting there. Okay, so for 13, yes, Mr. Seamon. The arc length is gonna be the integral from what to what?
From 0 to 2.
0 to 2 of the square root of.
Oh my goodness, that much.
1 plus what?
1 plus so it's the derivative of 1 over x.
1 over x plus 1 squared dx.
Yeah.
There it is. Nice. Find the arc length. Nice. So on that one right there, is that something you can do by hand? I don't think so, unless you guys came up with something really creative. And I will tell you that you, as a group, absolutely are going to be way more creative about these integrals than I could possibly be, especially since most of you by yourself are more creative with integrating than I can be. So I don't think so. I mean, maybe. Let me just want to know. It does come out to be about 2.302. Yeah, correct. What's the setup of the integral going to be? 0 to what? 2 of the square root of 1 plus 1/2 4 minus x squared times 2x, all what? Oh, negative 2x, all what? Squared. There it is. I think it cleans up okay. 0 to 2 of 1 plus, it's going to be x squared, right? X squared 4 minus x squared to the, is that what it simplifies to? Did I get all
It
that?
should be negative.
Negative by half.
Should it be negative? I think it should be negative. No, you're right. It is negative, isn't it? It is negative. It is negative. Or is it negative?
No, but you squared it, so I think so.
Oh, but I have to be careful here.
Oh, it should be.
It is no. The 2 cancels right there. That cancels, right? But then the negative gets the negative itself gets squared. So is it positive or negative? It is positive. I was right. Okay, got it. Now that right there, maybe you can do by hand. What is this, number 14?
15.
This is 15? This one, I think there is, what is that? Circle radius 2, right? So this is a circle of radius 2 around the center. So if you go from x equals 0 to x equals 2, what are you looking at? You're looking at this all the way to there. X equals 0 to x equals 2, right? So how much of that circle are you looking at? I think it's a quarter of the circle, right? So the point is you can recognize it as a quarter of the circle, and then do you have a form? Oh, you have pi times diameter is circumference, right? So that's how they do this one. They're like, this is 1/4 of the circumference of a circle of radius 2. Done. Like, ah. Anyway, because that has a nice answer, I think there's a way to use trig substitution on this one. What's important right now is we're not focusing on the integration method right now or that cool observation. Although that cool observation is cool, that's annoying because it's something you either see or you don't. There's no like process. Like you just need to be able to get to the point where you see the square root of 4 minus 6. Oh, that's the upper half of the circle, right? Nah. Can you tell me what happens when a particle is at rest? True. The velocity equals 0. Correct. For the velocity to equal 0, you know that the rate of change of its x component and its y component of motion have to both be
0.
They each have to be 0, right? So in this case, what is dx dt equal to?
With dx dt.
What's dx dt equal to?
3t squared.
3x squared minus, or 3t squared minus what? 3t squared. Why am I doing x's? I don't know. 3t squared minus t. Well, that tells you that that's equal to 3t times what?
It's 3t minus square.
Sorry, t times. I wish I could actually factor or do math today. 3t minus 1. So we know that the particle is not moving horizontally. Its horizontal motion is static when t is equal to 0 or t is equal to. Did I factor that right? Oh, it's 3.
3t minus.
It's 3. Can you guys? It's 3t. Isn't it 3t squared minus 3, and I'm just not factoring correctly or just doing any basic math correctly? You're like, yes, Mr. Seamon, that is correct. You are just being terrible at math today, but no, we're too nice to say anything. Let you find your own error. So this is equal to 0 when t is equal to 1 or negative 1. Okay, so you know the particle is not moving side to side. That is stopped moving horizontally when t is equal to 1 or negative 1. So all you need to do now is check dy dt. What's that equal to? 2t minus 2. So what's dy dt when t is equal to 1?
0.
2 times 1 minus 2 is 0. But also check, what is dy dt when t is equal to negative 1? 2 times negative 1 minus 2 is? So at time equals negative 1, the particle is not moving horizontally, it's moving straight down. So that we just checked, and it's not. It helps us answer a later question. But what does all this work tell us?
That t equals 0.
Not moving when what?
Both were 0.
When both are 0. So that's when t is equal to
1.
T is equal to 1. The question also asks where is the particle? A lot of you just didn't say where. Well, some of you didn't. So how do you find out where the particle is? You plug in the x and y values right there. You plug in the x and y values right there. When at, what's the point? I think it's negative 2 comma 1. Negative 2 comma negative 1. So it's not moving here. Yes, Brendan. What conditions do you have to go straight up or down, James?
So,
What's one condition you need to have?
so straight up or straight down is going to be just, so the dx dt has to be 0.
Okay, that's one condition. dx dt must be 0. And what's the second condition? There's something else that has to be true. Someone else tell me. And what has to? Henry. And what else has to be true?
I said that
dy dt. dy dt. No, we're just doing dy dt. We're in parametric land. Nope. It can't be 0. It can't be 0. If both of them are 0, it's not going anywhere. But it's moving straight up or down when it's not moving horizontally, but it is moving up or down. So what's the first thing you should do? Oh, we know that dx dt, sorry, not dt. We know that dx dt equals 0 when what's true? When t is equal to 1 or negative 1, correct? So you checked this already, and you know that dy dt when t equals -1 is 0. So it stopped there. But what is dy dt when t is -1? -4.
Still moving.
So it's straight down. Straight down at what time?
T equals -1.
When t equals -1. And what point is it at when t equals -1? And where? Where is it? Where is it?
So it should be
Plug in -1 right there, guys. What do you get?
2, 3.
What do you get?
2, 3.
2 and
3.
2, 3. Any questions on what do we know? What is dy dt? 2t minus 2? dy dt equals 0 when what is true? When t is equal to 1, I think?
-1.
When it's equal to 1, right? Because dy dt is 2t minus 2. Okay, but what is, we know that dx dt, what is dx dt? 3t squared minus,
3.
so what is dx dt when t is 1?
0.
It is equal to
0.
0. So what does that tell you?
Never.
It is never moving horizontally, because the only time it's not moving up or down is also when it is not moving side to side. It has stopped. It has stopped there. So let's just do some colored circling here. When I say your name, stand up. Let's do this here. Sean, Matt, someone who's blank and didn't put their name in. Ray, right there, and James, right there. Stand up. Okay, you guys are going to go to, as a group, find a group over in the back. And then, let's see, who did 8.2 right here? We have Jesse, James, Henry, Ty, Eaton, and John. You guys get into a group. And then, Brendan and Evans. You guys get into a group together. Please group up right now. So hold on. So just so you remember, if you needed to find dy dx, sorry, excuse me, not dy dx. If you want to find the second derivative like this, what did you have to do?
You add dy dx
Correct. So this dt of what? dy dx. Sorry, dy dx all over what? dx dt. Exactly. No, just that. It's that. It's that. So we're gonna do that right now. We'll do that right now. So the idea is, what should you find first if you're trying to find the second derivative? You should find the dy dx. So if you do dy dx, you know that dy dx is equal to dy dt over dx dt, like that. So dy dt, that's going to be, what is that going to be? 2 what? 2t over 3t squared plus 1. Exactly. So now what do we have to do to this? To find this numerator right here, what do we need to do to that thing right there? We need to take
It's a chain rule.
the second derivative. We have to apply the chain rule and find the derivative of that with respect to 2t. Exactly. So quotient rule. So we're doing d dt of 2t over 3t squared plus 1. Low d high minus high d low. So 3t squared. Low. Hold on one sec. Low d high minus high. What's the derivative of low? What's 6t, exactly. All over what? 3t squared plus 1 squared. Oh, it blinked back. OneNote does that. Now, what should you do to this before you go on to the next step? What would be a good thing to do to this? Simplify. Do you multiply out the denominator? Should you multiply out the denominator? No. You should clean up the top. How many square? You end up with what? 6t squared plus 2 minus 12t squared over 3t squared plus 1 squared.
You just need to find out if it's positive or negative.
I understand, but it asks you to find it. So well, for this one it says find it. Find it. So what is it? Negative 6t squared plus 2 over 3t squared plus 1 squared. So we just found the numerator. What is this right here? the
For the text dt.
oh, I just totally did that. Hold on. There we go. Where did the what go?
Oh, they're both.
They're both t squared, so it became negative 6t squared. So this right here is the numerator we were looking for. Do you agree? Are we okay with that? So that is the numerator right here. We just found it. So what do we have to put that over? What's the denominator of the fraction?
dx.
dx dt. And do we have dx dt? It's 3t squared plus 1. So what does this become? Negative 6t squared plus 2 all over what? 3t squared plus 1 to the what power? Cube. Yep, there it is.